Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 35, we will cover sewage systems, part 3. The different concepts that we will cover in this lecture are on decentralized sewerage systems. Within that, we will talk about simplified sewerage, small bore sewer systems, shallow sewer systems. Then we will talk about decentralized wastewater treatment system, DWATs, and secondary treatment and disposal of effluent. And after that, we will talk about public toilets, community toilets, and slum sanitation. So, when we talk about decentralized systems, as you can see in this particular image, the first one is a centralized system. That means we have a STP, and all the buildings in this particular area is connected via sewer lines directly to this particular STP. But when we talk about decentralized systems, then definitely we can have STP over here one, because this is too far away to be connected. So, we have a system where there is a sewer line and it is connected with a local STP where it is getting treated. So, this is one STP, then there is another STP which takes care of the existing network, and then there could, these buildings are too far apart and less dense. So, we can actually have on-site systems for this particular area. So, it is a mix of both on-site system, a decentralized system, as well as the standard conventional sewerage network system. So, we can call it incremental sewerage as well. So, gradually we can build over time, and we can gradually add some of this different kind of systems together and gradually build up the network for sewerage system of that particular area. So, in decentralized sewerage system, we usually treat, reuse or dispose the sewage near to source of its generation. So, that means usually this treatment is done near to the source, and also disposal is also done, disposal or reuse is also done near to the source as well. So, that is the difference with the normal sewage treatment, that is where the sewage is actually conveyed via sewer lines to a far away treatment plant. Instead, we are doing it locally. Now, what are the benefits of this then? This is suitable for small and low density communities, buildings in isolated areas, and sometimes even in existing developed areas like slum where alternative systems are infeasible. So, sometimes if I need to connect this area with the main line, we have to extend the pipeline, and actually when we extend the pipeline it gradually goes below. So, because of the invert levels we have to provide slope to that pipeline. Sometimes it actually creates problems, right. So, then we have to have a lifting station for that sewage. So, it will increase the cost. So, sometimes to reduce that, it is better to construct a local treatment, or in cases like slums, because there is no space at all, then also we can go for this kind of system. Then one of the primary purpose is of course preservation of primary health and environment. Then another main reason or benefit, you can say, improvement over existing on-site systems and a cheaper alternative to conventional sewerage and treatment system. So, that means we are getting almost the benefits of a conventional sewerage and treatment system instead of the on-site system, and but at a relatively lower cost. So, that is the primary benefit, and this is also done when the domestic water supply is limited. That means we are not able to provide 135 LPCD of water. So, that is one. The other is STP capacity may be limited and expansion is not possible. That means already the STP has been built, the capacity is already there is no further capacity to add extra sewage into this particular STP, right. And or maybe disruption of the community due to expansion, finance may not be available to do so much amount of construction. So there could be so many reasons why communities go for this decentralized treatment systems. Then there could be environmental reasons as well, to ensure limited quantity of effluent discharge. So that means we want to treat the STP over this sewage over locally and then reuse it for some purpose, but over here and that actually will reduce the total discharge from this STP. So if I want to reduce the discharge of effluents, that is one way to go for decentralized treatment. Then this kind of system actually we can predict the sewage generation and all these things easily, and the fluctuations, the prediction is much easier because we have to deal with only a few buildings, or a few means much less number of buildings, and then limited chance of mishaps. Small size sewer, we are not going to have large diameter pipes. Ecology of receiving bodies are not disrupted because of the low quantity of sewage. The bodies are able to take that kind of sewage load, whereas in case of the final treatment, if we put it in the river, then the load may be too high for that river to take. If the river is not that wide, it does not have that much amount of water, and so on. Then localized water reuse opportunities and targeted treatment for specific sewage constituents. So that means in particular area we can have specific treatments specified for that area as well. So these are the different reasons why we go for decentralized sewerage systems. So in addition to that, we know that in conventional sewerage systems there is a lot of idle investment. That means we have to construct a lot of pipeline which would be not used, and then there could be theft and misuse of those kind of systems. And then another issue is house service connection, because the cost has to be borne by house owners. They may be unwilling to connect their building with the sewerage network, or they may be actually constructing the sewerage network, constructing the building much later than the sewerage network. So there would be repeated cuts of the road to accommodate this connection by different owners, right? So this is a problem. So so there could be a provision to extend the connection from the sewerage line to the property boundary, and applicant pays when the house is built. So this could be possible, but this is all idle investment by the municipality. That means municipality will lay the sewer, build these connections to every plot, and then all this money would be invested, and maybe the plot would never be developed, or people may build a house much later, right? So there is no point of doing this kind of investment. So recovery of sewer cost, public acceptance, these are other issues. That means why we go for decentralized systems. So there are different kinds of decentralized systems. These are simplified sewerage, small bore sewer system, shallow sewer system, twin drain system, and then we also do their treatment as well. So what is simplified sewerage? So we can say that it's sort of a more flexible system where we overlook some of the conservative design standards of sewerage pipeline sewer networks, and we can say it's a flexible system of sewer network design as per the local situation. And tertiary sewers can be located in private or semi-private space. That means, as you can see, we have the pavement below which the sewer line is going. Then this is one lane which is going in. So there is a sewer laid along the lane. But over here there is no lane, but we have put in the sewer so that we can serve these particular houses. And this is at the backyard of that particular plots. So it's an unconventional way of laying sewer lines, but this is actually an efficient way because you are able to serve most of the plots from their back, of course. So this is more like an informal way of laying your sewer pipelines. So that's all. So it's not very complicated, and sewers are laid at shallow depths, cover of 400 millimeter or less, and then sewer diameter 100 millimeter and minimum, whereas 150 mm is standard, which is also standard for normal sewer lines as well. But the idea behind this is, instead of going for very formal networks, we can go with informal network and lower depths for this final branch lines or this connection lines to the individual houses, and this could be done in an informal manner to accommodate all the different plots, all the different buildings, which would otherwise may not have been served. Maybe in a slum area this is a good approach. Then comes the small bore sewer system. So, as it's evident from the term itself, small bore refers to smaller diameter pipelines. So, in this case, primarily the sewer system is designed to collect the effluent from septic tanks and aquaprives for off-site treatment and disposal. Suppose in a slum, there is a toilet which is constructed and then there is a septic tank, but we do not have space for this dispersion trenches. So, that means we have to take this effluent far away for treatment. So, probably that is where we will go for a small bore sewer system, or these are designed for conveying only the settled sewage, mostly water, because settled sewage means in a septic tank or aquaprive and so on, which allows lower flow velocity. Because it only carries water, we can have more flatter slopes and lower flow velocities in the pipelines. And this leads to reduction in cost in terms of excavation. That means, we can only need to excavate until a little distance. The pipeline material and treatment methods are also relatively cheaper in that case, because we are only dealing with effluent part. And this is a logical upgrade from the existing on-site system facilities to similar services as a conventional system, because we have got septic tank. Now, we are also able to get rid of the effluent using a sort of a sewer system. And this could be adopted for new development in fringe areas, and this could be applied in areas where groundwater level is high. Groundwater level is high, or there is no space for effluent and sewage treatment. So, as we were just discussing, particularly for slums, this kind of method is going to be very useful. So, how are the system designed? So, we have the toilet, this is our septic tank, then this is connected with this instead of soakway or a dispersion trench, we can connect it with a small bore pipeline to the main sewer line, or it could be taken to an independent treatment unit as well. So, it could be a treatment unit like a upflow filter which is far away from this community, or it could be a common treatment plant for this community, or it could be connecting this water to the standard pipe sewerage system, or the standard conventional sewerage system which is already there in the this particular urban area. So, in many cases slums are connected to the standard sewerage system like this. So, so in this small bore sewer system, we have got other components as well. So, we have the house connection part, we have an interceptor tank, then we have the sewers, then cleanouts, and if there is a sewer pipeline, there has to be certain cleanouts or manholes through which you can access the pipeline to clean for blockages and all this, and then vents and lifting stations. Lifting stations, if the pipeline is too long, then probably there may be a requirement for a lifting station as well. So, multiple sewer connections, multiple houses, particularly in dense areas, could be connected to one septic tank or an interceptor tank, and then effluent goes into the small bore system and follows gravity flow. Diameter of the pipelines and available slopes are, as we have discussed, slope is not that much required, and minimum diameter is 100 mm, and we can use Manning's formula for pipe flowing full, that we can assume that the pipe would be more or less full, and we can use Manning's formula for estimating pipe diameters and everything else. And minimum self cleaning velocity is not necessary in this particular case, because we are only dealing with liquid, and hydraulic gradient remains below all interceptor tank outlet inverts. So, that means wherever is the invert level of that outlet, the hydraulic gradient has to be below that for the sewer network. And ventilation is not necessary, but we can add vents, and vent clean out to release air may be provided like this one. So, which is this is the pipeline, and then this is the clean out structure. So, we can open it, and then we can in case of blockages and release of gases, we can use this. Then shallow sewer system is where it is almost same as the previous one, that is the small bore system, but the only difference is we do not have a septic tank. We directly connect the toilets with this particular sewer system. So, a shallow sewer system consists of pipes laid at a minimum gradient below sidewalks, lanes and backyards of planned and unplanned settlements, provided heavy load is not present. and concrete encasement in case of heavy load. So, this is the basic system. That means, we have a toilet, and out of the toilet there is a inspection box. This house connection, there is toilets are connected to an inspection chamber via 75 mm diameter pipe, and then sullage is also connected to the inspection chamber directly if it is greater than 75 LPCT water, otherwise through a grit and grease trap. And then we have got inspection chambers along the way, and along the street collectors and laterals at intervals of every 40 meters there could be inspection boxes like junction box like that. Multiple houses may share a single inspection chamber, and chamber is provided with tight fitting RCC cover. So, that means, we have got this inspection box over here, and then we can have other inspection boxes, or we can call them junction boxes, where multiple lines actually come and get added, and we can have multiple connections to a single inspection box, that is possible. So, it's a more more informal system compared to a conventional sewerage network. The sewers are designed, these are again minimum diameter is around 100 mm, made of concrete, and the depth of the pipe invert minimum is 0.4 meter, and for the street collectors it would be around 100 to 150 millimeter, and we can have community septic tanks at the end of lateral sewers, and then we can go for small bore sewers for street sewers, and pumping station is rarely required. So, you see that instead of the in the last small bore sewers, the septic tank was near the house, and then we were conveying the effluent out, and then connecting it to an existing sewerage network, or we could even go to take it for further treatment. In this shallow sewer system, that means, we are not having a septic tank inside the community. Instead, we are having a septic tank maybe outside the community, where the entire sewage is actually brought through again small diameter pipelines at shallow levels, and this below the drains, or below the footpaths, and all these drains can actually be conveyed, and then then we use this inspection boxes and all, or junction boxes for further connections, and through which the sewage is transported to a septic tank, maybe where it gets treated. So, wherever we have space to construct a septic tank, we will construct it, and then the sewer could come to that, and then we can do treatment, or eventually we can also connect it with the conventional sewerage system as well. So, then comes the decentralized wastewater treatment system, or DWATS, and in this particular system, it is particularly a non-mechanized system, and it is a affordable as well as low maintenance treatment system in case where adequate land area is available. So, that means, in the main challenge is land area has to be available. So, it is possible in areas where, like semi-urban areas and all these places, or where or areas which are not that dense, that is possible there. So, both physical as well as biological treatments are employed. So, let us look at to the various treatments that are being employed. One is pre-treatment settler, that means, we allow the sewage to settle. Retention time is around 2 hours, and this leads to BOD reduction of around 30%. So, that means, some amount of sedimentation happens, and that actually leads to reduction of BOD by 30%. Then anaerobic baffled tank reactors. So, we know what is the anaerobic baffled tank reactor. So, retention time is around 24 hours, and BOD reduction is around 80%. Then anaerobic reactor is where the media is there, and this sewage gets mixed with the media and gets acted upon by the bacteria in this particular media, and it gets digested. Then we have the anaerobic filter, where retention time is around 8 hours and BOD reduction is still 90%. So, anaerobic filters are also used, and then planted gravel filter, which is retention time is around 36 hours and BOD reduction is around 90%, and then we can have a polishing pond as well. I will explain. Polishing pond is finally giving a final treatment to the effluent or the liquid waste, so that it is relatively pure. So, that is why we call it a polishing pond. Now, you can see in this particular image, we have got the sedimentation. The first step is sedimentation, and we can, for that we can have sedimentation pool, we can have a septic tank, or we can even have a biogas plant or this mixed digester as well. So, these are the three options to actually allow sedimentation, and this also will result in sludge which has to be removed, and this begins the anaerobic fermentation, or and the sludge is already collected. And then in the next stage we have got anaerobic digestion over here. So, we have got an anaerobic baffled filter. So, as we have discussed last time, that there is a settling tank, the water goes down, then gradually there could be an upflow filter, goes via the media, and it could be without media. This is with media and this is without media as well. So, gradually we can treat the water, treat the effluent from this particular septic tank and all. So, we automatically it gets treated to certain extent, and then we have got aerobic and facultative decomposition, which is basically what we do is there is a planted gravel filter, and there are plants involved as well. So, over here the water is some amount of aerobic decomposition takes place in addition to the anaerobic processes that goes on. So, and then finally post treatment we can actually have a aerobic facultative pond and aerobic finishing pond, polishing pond, through which we can do that removal of suspended digested solid and active bacterial mass, and finally the entire sludge is, the final sludge is actually comes to the bottom, and we get mostly clean water. So, this is the basic DWAT system. So, as you can see, it is a mix of different kind of systems, and some are physical, some are biological. So, we have discussed all this earlier as well, but when you put this in sequence, we can call it a decentralized wastewater treatment system. Now, we will discuss about, now that we have discussed about on-site sanitation facilities as well as decentralized sanitation systems, we have to talk also about the public toilets and the community toilets that are also could be called as part of the on-site treatment process, or does not matter, because in urban areas also we need to provide public toilets at certain intervals, and also that people who are traveling or along in the streets, they also they can use this particular facilities, right. But community toilets, again in slum areas where there is no space for setting up septic tanks or even individual toilets as houses, we can have community toilets as well. And public toilets could be also provided in case of meeting, in case of fairgrounds or in parks and so on, right. So, these are the systems which are part of the entire sanitation system, but we cannot say it is part of exactly of decentralized or centralized system, but it is a unit which also needs to be studied. So, in case of public toilets, the rule is public toilets should be provided in urban areas, places like stations or along streets at every 1 kilometer, including in parks, plazas, fuel stations, etc., and should be for universal access for 24 hours. So, that means for throughout the 24 hours we should allow access to it. So, the maintenance of these toilets or access to these toilets are the responsibility of local governments, residents, private or non-government organizations. So, sometimes the governments construct this kind of toilets, sometimes the community organizations or the local residents construct this kind of toilets, sometimes even NGOs or private organizations sometimes set up this kind of toilets. And usually we find there is separate section for males and females, and standalone toilets for transgender, and also standalone toilets. Also we provide toilets for differently abled persons as well. In the female section we allow child caring facilities as well, where a child's diapers could be changed and so on. Provision of dedicated toilets for differently abled persons, with western toilet, guide rails on both walls, water faucet for ablution and wash basin at chair level. So, all this is also provided, and both male and female attendant is present in each toilet, and there has to be a sort of a charge sometimes for maintenance of this particular toilets. So, you can see some basic designs of common toilet arrangements, as well as these are those standards, like how many water closets for male and female has to be provided. Based on that we can design the toilet. For example, 1 per 100 persons up to 400 persons, and for over 400 persons we can add at the rate of 1 per 250 persons or part thereof. So, similarly for female we can have 2 per 100 persons and so on. So, how many water closets are required? So, it is dependent on the number of people who will use this toilet. So, in public facilities and all, we have to make those estimates, and based on that we have to provide the number of water closets or number of ablution taps, 1 in each WCs, then urinals, 1 for 50 persons or part thereof, and then wash basins. So, in that way we have to provide this kind of facilities in this toilet. Then we come to community toilets. Unlike public toilets, these are used by fixed number of users. So, that means we design the toilets for a particular community or a particular group of people within that community, right? Or we can have multiple community toilets for a particular community. So, there is a fixed number of users, and based on that we will determine the number of WCs required, number of these taps and urinals required, and maybe bathing areas requirement. So, these toilets are provided where it is difficult to construct toilets within residence or inadequate space for on-site treatment of sewage or far away from sewerage or at places of gatherings. And usually for economically weaker section in slums, educational institutions or cluster of dwellings away from sewerage networks. And this usually have got a washing section and a bathing section, right. So, you can see that these are some images of community toilets, and it also needs to be cleaned by staff members or people who are engaged for cleaning this kind of toilets. We have to make sure that because it is a community toilet, it needs to be regularly cleaned. So, when we design community toilets, we have to be considering several parameters because it's a toilet which is designed for the community. So, we have to take the preferences of the community, and the preferences are in regards to various aspects. For example, we need to ensure that because it is used by the community, that means security at night for children and women, right. So, this is primary concern. There has to be adequate lights and all. Accessibility in night, if it is in an area where there is lot of the roads are not good, or there is lot of maybe it's a rural area, then there is chances of snake bite in those roads. So, accessibility, safe accessibility is important. Safety from pest, yeah, that is what I was talking about. Security of toilet accessories, that means things doesn't get stolen. Then maintenance and disposal, what is the type of disposal system, how is the roof and the door and the building structure design. Then design of the toilet block could include the toilet seat type, area of latrine, availability of bathing area, availability of urinals, if flushing system is there, then time taken, then distance to how far away it is for the people who would use it, how much time it takes to walk to that particular toilet, then how many toilets are available or how many seats are available per number of user. That means one WC serves how many number of people, right. So, these are the different parameters that has to be considered. So, you can see these are some other considerations. For example, operation and maintenance, treatment method of sewage, user perception, community culture and beliefs of that community if it is taken care of, socioeconomic background, gender consideration, then privacy of women, comfort, convenience of use, water availability, cleanliness, then coverage of toilet, if all the areas are covered or not. One is how many number of seats, that is important, that is one toilet would be used by how many people. The other is if the toilet is available for everywhere, means the distance or access time is less. So, the coverage of toilet is also important. So, in addition, we also look into the land tenure, affordability of that particular community, cost of the facility, cost of maintenance, reuse if is possible of the waste. All these things also could be looked when we design community toilets. So, finally, we come down to slum sanitation, which is a big challenge in the Indian context. As it's evident from that particular image, slums are usually developed around water bodies because the primary need for sanitation actually drives people to construct slums or this kind of housing around water bodies, so that the waste could be easily disposed of. So, that is evident in the image as well. So, a slum is a compact settlement of at least 20 households with a collection of poorly built tenements, mostly of temporary nature, crowded together, usually with inadequate sanitary and drinking water facilities in unhygienic condition. So, this is the definition from Census of India. So, in Mumbai, to just give you a snapshot, around 49% of Mumbai's population, of course, as per 2001 census, are slum dwellers, and there are around 2000 slum settlements in Mumbai. Then in 2011 census, it was found that 70.73% are these slums are connected to closed drains, 26% to open drains, and rest 3.1% do not have access to even drains. Then individual latrine within premises, around 32.82% of buildings have within the slums have got toilets within latrines. So, rest most of them, and out of this 32.82%, 68.9% is connected to pipe sewer network, 19.6% to septic tanks, 3.2% to other systems, and 3.8% is peat latrines. And 3.65% is discharged to open drains, and 1.3% removed by human or animals, some form of system where manually it is the excreta is removed, which you can understand is a conservancy system. So, public and community toilets is rest 64% of the population who doesn't have individual toilets uses public or community toilets, and 3.12% was found to defecate in the open. And so, this actually results in the sewage discharge into nalas and creeks. This is pretty common, as we were discussing. So, these are some of the issues that we see in slums. So, community toilets are a part of slum, and in most cases community toilets, the government actually construct community toilets, and it could be designed or provided based on two approaches. One is the supply side driven sanitation. So, that is where we provide the emphasis is on provision of the infrastructure, and the community preferences, practices, beliefs are not too much taken into consideration. So, there is a standard design, the government comes and constructs some community toilets, and this, and also the community, there is not much of participation, and we have seen that in most cases this has resulted in failures. Wherever, like in case of Bombay Municipal Corporation till 1995, both constructed and maintained public community toilets in slums, and in 2001 survey it was observed that 39% blocks had electricity, only 39% blocks, 14% water supply, 31% connected to sewers, and the rest of the blocks connected to septic tanks or aqua-privy systems. So, this is the system, and these are plagued by poor maintenance, default design of toilet, and no proper consultation with the community. So, these are the kind of toilets you can see designed, and because the community is not taken into consideration or not into the consensus or the decision making process, that actually led to design of structures which were poorly designed, as well as not maintained properly, and so on. In 2014 survey, however, it was found that many of these toilets were repaired and upgraded by the Maharashtra Housing and Area Development Authority under local area development funds, and it was found that the standard design is around 5 to 7 feet above ground, and 10 seats with separate male female sections, no water or electricity connections are still there, and maintenance is done by Mumbai Municipal Corporation of Greater Mumbai conservancy workers. So, it is done from the government, or it was done by user collectives or hired cleaner with contributions from the community, like 250 households contributing 30 or 50 rupees per month, and then vigilance is done by the families, and usually we find around 100 users per seat. So, that is the standard of this supply driven sanitation, even though it is modified, upgraded, but still there are we have to deal with 100 users per seat, which is a pretty high number, and also the efficiency of cleaning and all, particularly in case where maintained by conservancy workers and all from the municipality, probably may not be good enough for this particular communities. So, there has been also situations where toilets have been constructed based on demand driven approach, where emphasis was on community participation, user needs and preferences. That means the community has been taken into confidence, their opinion was taken, and the slum sanitation program starting from 1997 onwards, financed by the World Bank and the Mumbai, particularly in the Mumbai sewage disposal project. This was an example of this demand driven approach, and community toilet box with higher standards were designed, and this was a partnership between the community based organizations, non-governmental organizations, the contractors, and it's a participative and bottom up approach. And you can see the image of this community toilets. These are 2-story structures were also constructed. So, standard design is double-storied RCC structures, separate male-female sections, 40 toilets instead of 10 toilets earlier, 20 each for men and women, urinals, bathing areas, caretaker rooms, electricity and water connections, all these things were present. And then maintenance was via community-based organizations, and in some cases multiple resident groups, there were difficulty in consensus. So, that is the only problem. Whenever there are different residents groups and all, there may be some sort of disagreements and all, but in overall general there was no issues, and typical charges are ₹2 per use and monthly pass of ₹30, and there are usually 2 to 3 caretakers per toilet. So, this is how a toilet is being designed. You can see in the images, these are looks much better than the earlier ones. So, we also did in some of our research in our laboratory, we also did some research on what people want from in these slums and all, and we were in Mumbai also in 2013, we did some surveys, particularly in a ward in Andheri, and we found that existing users vary from 120 to 45. But when people were asked about at what levels they were comfortable based on the use time and all this, we found that this could be achieved around 45 users per seat is the ideal number, whereas the existing values in some cases were pretty high like 120, but in some cases we also find 45 is good, and acceptable satisfied users are at 55 to 60 users per seat. So, this is maximum satisfaction, but people would accept around 60 users per seat, they are more or less okay with that particular design. This desirable distance is 5 minutes, that means people do not want to walk more than 5 minutes, and acceptable distance is 5.7 to 6 minutes. So, roughly more or less same. So, you can see that based on that we can design the coverage of the toilets. That means within 6 minutes of walking distance we need to construct a community toilet. So, based on that we can have multiple community toilets even within the one slum, and that actually takes care of the coverage, and the number of WCs or the number of urinals or the number of seats inside toilets could be decided based on these standards, where we can see that around 50 to 60 users people were more or less happy. So, I think that is what is shown over here. As you can see in this chart, satisfied people, you can see at 90%, 90 seats, 90 users per seat, people are satisfaction level is almost 0. It gradually improves, and we can see that around 85% of people are satisfied, around 60 persons per seat, and then at around 45 to 60 you can see most of the people are satisfied. So, this is one similar distance from toilet. You can see that existing range starts from 15 minutes to 10 minutes and so on. So, people are more or less satisfied when the distance is around 5 to 6 minutes. So, this is the range that they want. Then area inside toilets also, they want within the toilet at around 10 square feet, the satisfaction level is around 20%, but when it improves to around 13 to 14 square feet, people are more or less happy. So, these are the kind of studies that actually needs to be conducted to get user opinion on what sort of toilets or community toilets should be provided, and if this kind of community toilets, or not even community toilets, even toilets that are provided for under open defecation free ODF, Swachh Bharat mission and all this, if this kind of standards are made, then automatically people would be satisfied and people would be using those toilets, right. So, that is what we should target. So, that is how we can actually incorporate the community's feedback or community's decisions in actually deciding on what sort of services should be provided. So, to conclude, decentralized sewerage system is an improvement over existing on-site systems and a cheaper alternative to conventional sewerage and treatment systems. Demand-driven approach results in more acceptable sanitation facilities compared to supply-driven approach. And community toilets has to be designed considering service attribute levels based on user perception. That means whatever user gives them satisfaction, that should be the basis of design of community toilets. These are the references you can consider. Thank you.